Good afternoon, class. Today we're going to do section 1.7. It's going to involve the distributive property, so a little bit of a refresher, but we're going to add some advanced things to it today. So here's the distributive property. Again, this is going to be a key concept that you could write on your key concept sheet to use on tests and quizzes. This left column over here is the stuff you can have on your key concept sheet. The examples over here you would not be allowed to have, but this will explain what to do. So the distributive property as it is presented here, we're looking at the A here can be distributed or multiplied by both of the items on inside the parentheses. Now we use the distributive property when there's adding or subtraction going on inside the parentheses. So this letter here, A, next to the parentheses, telling us to multiply by this sum. So we take that A and we just put it on both variables that are inside. So A goes next to B and A goes next to C. The distributive property is also when the number or letter is outside the parenthesis on the right. This is the same thing. If you remember the commutative property that we spoke of in the properties for real numbers, we can move this A out front and get the same result. So B times A is the same thing as A times B. So distributive property does the same thing whether we're multiplying after the parenthesis or before the parenthesis. Here, when we're distributing into a minus, just remember to keep the minus that was inside the parentheses in your answer. Same thing over here. The A can be distributed even though it's after the parenthesis the same way. Just remember to keep your subtraction there inside the parenthesis. So now we'll go through some examples. Here you can read through these examples as I work through them. So we would do 3 times 10 here. So 3 times 10 and then 3 times 4 over here. Well, my writing's getting a little bad here, so I'm going to redo that. And then we could actually multiply them and add them up. So we would get 30 plus 12, which is 42. We would get the same thing if we came over here and did 10 times 4. Excuse me, 10 plus 4 got 14, and multiplied by 3, we'd still get 42. So the same result, we're just practicing the distributive property. You can go ahead and do these for practice, but the idea is to take this number and just multiply it by both the 5 and the 3 to get 35 plus 21. So we're going to get 56. So again, you could take 5 and 3 and add them to get 8. 8 times 7 is 56, so you get the same result. So we will go through some more examples as we get into the problems here. The next thing we're going to do is we're going to deal with some variables. Typically, the distributive property is done when we're working with variables. So in this case, we're going to take 5 times x and 5 times 7. So I'll just distribute that. So 5 times x plus, remember to keep the plus sign there, 5 times 7. Now we do have to simplify. When we do 5 times x, we just write it as 5x. You can remove the multiplication symbol and just do 5x plus, and then just multiply those to get 35. We can work with fractions just like we do whole numbers. So when we're working with this problem over here, we're going to multiply the 12 by the 3 here. So this 12 and 3 can be multiplied. And then we can multiply the 12 and the 1/6 t. Now remember to keep the minus in there because that's part of the problem. So when we multiply 12 and 1/6 t, our variable stays in the problem. We're just got to multiply this whole number in this fraction. So 12 times 3, we're just going to get 36 minus. Now we have to take 12 and multiply by 1/6. So if you don't have your calculator, you're going to have to do 12 times 1 and 1 times 6. We're just multiplying a fraction, and then t. So now we have to simplify this fraction here. So our final answer is going to be 36 minus 2t. 6 goes into 12 2 times. So then here is your final answer after we've distributed the 12. Here's how we would work with fractions. If you remember when we were doing order of operations, fractions are just like parentheses. And when we are going to be dealing with fractions with the distributive property, we're going to be distributing a fraction to both. So this 3 can be distributed to the 4x and the 6, and just write it as a fraction. So 4x can be put over 3 minus 16 over 3. Now all we have to do is simplify, or just leave it in fraction form if it can be. If this fraction could be reduced, then we would do so. 16 over 3 just stays as a fraction. You can write it as a mixed number or as a improper fraction, either way. Either answer would be correct here, just as long as you reduce. So 4/3 x is the same thing as 4x over 3. You're going to see us write the variable often next to the fraction here. So let me change color here so I can explain what I'm doing here. 4/3 x is the same thing as 4x over 3. You'll see it written both ways. They both mean the same thing. Now, anytime we have a negative outside the parenthesis, we're going to treat that as a -1. So you're going to see this often, and you're going to see it where this is really a subtraction problem, and we'll teach you how to rewrite that as plus a negative. So you understand that that minus or that negative has to be distributed just like any number out front. So we're going to rewrite this as -1 parenthesis a plus 5, and we're going to distribute the -1. So we get -1a plus -5. This here can be rewritten. Anytime you're adding a negative, you can rewrite that as -5. So distribute the -1, you get -1a minus 5. Now we can't simplify this any further. This is as far as we can go with this, and we'll explain that here shortly. Now let's talk a little bit about what it means to be a term and what it means to be like terms. A term is just a number, a variable, or the product of a number and a variable. So here's an example of a term. These are all terms here. We have a product here of 5 times x squared. So this is one term. Terms are separated by adding or subtraction. So we have 4 terms here. This has 2 variables in it, but it's still one term. This has 2 variables in it, one term. This is a term with no variable. We're going to talk about what that is called in just a moment, but let's talk about what it means to be a like term. Like terms mean they have the same variable, okay, and the same exponent. So in this case, these both are xy. These are considered to be like terms. Down here we have 3x squared and 5x squared, so those two are like terms. This is z squared w minus zw squared. Now these are not like terms. Even though they have the same variable, notice the squared is on the z and it's on the w here, so these are not like terms. So let's talk about what it means with this number in front of the variable, and what is that called, plus the number with no variable, as I pointed out up here, what that's called. Here we have 6a squared minus 5ab plus 3b minus 12. Each term in there is separated by a minus and a plus, so we have 4 terms here. A constant is the term on the end that has no variable here, so this is called a constant. A coefficient is the number here that's in front of each variable. So we have 6a squared minus 5 becomes a -5. We rewrite this as plus a negative. So any minuses have to be interpreted as negatives. And then we have a 3b. The 3 is the coefficient. And the coefficient is very important when we start combining like terms, because we have to identify what's the same. So let's do an example of that. Here's an example of combining like terms. Let's identify the terms. We have 3y minus y. Now, anytime a variable does not have a coefficient in front of it, we're going to rewrite it with 1. So this is really minus 1y. So when we're talking about coefficients, it's always the number in front of the variable. If there doesn't appear one, if one does not appear there, then you just put a 1. Now, in order to combine like terms, we're going to leave the variable alone. So we're going to combine the y's and just take 3 minus 1. So we get 3 minus 1 is 2. So 2y is what this simplifies to. And that's as far as you can simplify that one because there are no other terms to identify what y is, so we can only get 2y for our final answer. We'll be going through some examples in class, so bring your notes, answer the questions after the video, and come to class with your notes.